So we have a problem before us. Taking the first approximation as 2, okay, determine the root of the equation x squared. This is x squared minus 3 sine x plus 2 natural logarithm of x plus 1 is equal to 3.5. So we shall just say let f of x is equal to x squared minus 3 sine x plus 2 natural logarithm of x plus 1 minus 3.5. Move this to the other side, and then you make this your function f of x. Now, one of the things that we need to remember is how to differentiate this, and then how to substitute in the values in here. So you can do f prime of x, which is going to be, if I differentiate this x squared, I will get 2x minus, if I differentiate the sine, I get a cos, so 3 cos x. Saying if I differentiate the sine x with respect to x, I get a cos x. Then minus, okay, plus. Now this is natural logarithm, so natural logarithm, you differentiate what is inside here and divide it by this function which is in here. So that means I'll maintain my 2 there. Then I differentiate x plus 1. Okay. I differentiate. Sorry about that. I said I differentiate x plus 1 with respect to x. Then I divide it by x plus 1. So if I differentiate a constant, I get a 0. So what does that mean? My f, first derivative of f of x will equal to 2x minus 3 cos x plus 2 divided by x plus 1, because if I differentiate this with respect to x, I'll have this being 1, because the x of the x is 1, so x plus 1, and that's all. So it is from this that now I start using Newton Raphson method by approximating. We already know from Newton Raphson method, we know that R2 is equal to R1 minus f of R1 divided by f prime of R1. But already R1 is given as 2, because the first approximation has been given to us as 2. So what does that mean? I need to look for f. I need to get f R1, which I am going to substitute in the other function. So I have 2 squared minus 3 sine of 2, then obviously plus 2 natural logarithm of 2 plus 1, then minus 3.5. So I use my calculator. I have 2 squared minus 3 sine. I have to put my calculator in radians. So if you don't put it in radians and it is in degrees, that sign will bring you problems. So change your calculator to radians. So sine 2 plus 2 ln of 3, then minus 3.5. So this function, the value of this function at R1, which is 2, is giving me negative 0.03066 What about the value of the first derivative at x is equal to r1. This is going to be, we said this is 2 into 2 minus 3 cos of 2 plus 2 divided by 2 plus 1 minus 0. Even if we don't put that 0, doesn't do us any harm. So what is that going to be? We have 4 minus 3 cos of 2, then plus 2 divided by 3. And this is giving me 5.9151. So obviously, I start my approximation. Okay, so you can see these are the values. When you substitute in here, these are the values that you get. The negative 0.06 something, we had it up there. Okay, then you differentiate the function f of x. So the first derivative is 2x minus 3 cos x plus 2 out of x plus 1. And when we substitute in the value of x, which is r1 equal to 2, which is the first approximation of the root that has been given, we get that the value of the first derivative at that value of x as 5.9151. So what does that call us for? We start using Newton Raphson method. So apply Newton Raphson method. So that means our R2 will equal to R1 minus FR1 divided by F prime R1, which means what is R1? R1, we already have it as 2 minus the value of the function at R1, which is negative 0. We have it as negative 0.037. Divided by 5.9151. So you do this, I'm going to say negative 0.0307 divided by this value. I get 2 minus that value, and the first approximation R2 is equal to 2.00519. You go ahead, do the same. Okay, you do the same. You look for R3. Look for R3. So R2 is there. Look for R3 by using the Newton Raphson method. And you still see that the value is converging to R3 also equal to 2.005, which is approximately 2.01. So R2 and R3 are giving us the same value, and therefore we can say if we are to maintain that level of accuracy, of course, always get R3 minus R2, and then you get the error. The error always is 0. You can always make sure that it is above 0. It is not more than 0. For example, 0.005. Okay, so when that is the case, then obviously you have a high accurate value. So what does that mean? You can conclude that your value, the root of the function, is 2.01. So the root of the function is equal to 2.01 to 3 significant figures. So you have found one of the roots.